Hey guys, welcome to my channel, and in today's video we are going to solve one more LeetCode question, that is question number 3075, maximize happiness of selected children. So this is a medium level question, and in this question we are provided with the array named as happiness array, and the length of this array is n, where n represents the number of children and happiness I represents the happiness of ith child. And also we are provided with a positive integer k, where k is representing the number of turns or rounds. So in k rounds we have to select k childrens. That means in every round we have to select one child on the basis of the maximum happiness. So in one round we are going to select one child, and then we are going to sum up the happiness of all the selected childs, and the selection of these childs has to be done in such a way where the sum that we are going to get at the end is the maximum. The sum of the happiness has to be the maximum. And while we are selecting one child, in every step the rest of the unselected childs are experiencing decrease in happiness by 1. So if I show you in this example, so happiness array is 1, 2, 3, k is 2. So in first round I am going to take 3 because this is the maximum happiness, because this is the child with maximum happiness in comparison to other values. So currently my resultant sum is 3. When I am selecting 3, at the same time 2 and 1 are going to experience decrement. So it will become 0 and 1. Now in second round, as k is equivalent to 2, so I have to select 2 childs in 2 rounds. So in second round I am going to again take the maximum one because I have to increase the sum. So I am going to take 1 and add it up in the previous value that I had taken, that is 3. So total is 4, and in this manner we got the answer 4. So this is how we are going to obtain the maximum sum. Now there is one more constraint, that is when we are decreasing the happiness of the unselected children's, at that point of time we need to check whether the value is positive or not. Because if value is getting negative or the happiness is going into negative value, then it is not valid, because happiness value cannot become negative. So if the value is equivalent to 0, after that we are not going to decrease anything, or we are not going to reduce 1 from it. But if the value is greater than 0, then we are going to remove 1 from happiness. So let's understand this question even better with this example. So we can see that this example comprises of 4 children, and these 4 children have these respective happiness, and this is k, where k is 3. So now we have to find out 3 childs from this array, and we have to send the maximum happiness in return. We have to calculate the maximum happiness at the end. So the first brute force approach that I can think of is, if I want to calculate the maximum value, so every time I would like to start with the child with the maximum happiness. So for that what I can do is, I can simply sort this array and I can make it something like this. This will become 5, 4, 3 and 2. So now this array is sorted. Then I am saying I am having k rounds, that is 3 rounds. So in 3 rounds I have to select child one by one. And while I am going to select these child, at the same point of time I also have to manage that decrementing condition, correct? So if I say for this k will start from 0, so when k is 0 I am selecting 5, and then rest of the array will become 3, 2, 1. Now for k equivalent to 1 I am going to select 3. So rest of the array will become 1 and 0, and then k will become 2, and I am going to select 1 in this case. And as this is 0 and we know that we can't make happiness negative, or we can't reduce any further from this, because we need positive happiness in order to reduce from it. So we can't subtract anything from here, from this value, and we are going to keep it as it is. So as I have selected 3 values or 3 child from this array, which is this, and this, what I can do, I can simply see the total 5, 6, 7, 8, 9. So 9 is the maximum happiness that we are going to get. Answer is correct. But how we are going to apply this logic of maintaining rest of the array and decrementing value at the same time, how we are going to work with that? So if we are going to see this pattern, we can clearly see when k is 0 or we are at first step, we are selecting a value and we don't have to reduce anything from it, because this is the first child and first child is not going to experience any decrement in happiness, but the rest of the childs are going to experience decrease in their happiness. So what I saw is 5 minus 0 is going to be 5. Then in second round, what I saw, when k is 1 and if I am subtracting this from the original happiness of this kid, still I am getting the accurate happiness as per our condition. So 4 minus 1 is 3. This is what I observed. And in this step where k is 2, again I can see that original value minus k is also giving me 1, which is what I get right after applying the logic. So what I can do is, rather than doing much work or traversing this array multiple times or maintaining it in different array or anything else, whatever you can think of, rather than thinking much about this thing, we can simply subtract the k value that we are using as the number of step or the number of turns. So for every child, what we are going to do is, we are simply going to take its original happiness and we are going to subtract the index or the number of turn that we are currently working with. So when the turn is 0, we are going to subtract 0. When the turn is 1, we are going to subtract 1. When the turn is 2, we are going to subtract 2. In this manner, we only have to traverse this array once and we'll be able to calculate our answer. Let's quickly go through this algorithm. For that, let me just clean this board. So this is what we observed. Firstly, we are going to sort our array. After that, we are traversing this array. So for k equals to 0, I am taking 5 minus 0, which is equivalent to 5. So my resultant is going to be 5. Then for one step, I'll be at this index. So what I'm saying, now do 4 minus 1. And 4 minus 1 is 3. So what I will do, I will update my result with, then we are going to update our result with 3, which will become 8. Then for k equals to 2, we are going to, so we'll get 1. And again, we are going to update our result with 1. So we are going to get 9. And this is the actual answer that we are going to return. So in this manner, we have solved this question. So what will be the time complexity of this whole approach? So as we are using sorting, so sorting will take firstly n log n. After that, we are traversing the sorted array once, so it will take big O of n time. And these two combinedly will give us big O of n log n, because that is the dominating one. And this is the time complexity of this approach. And space complexity, we are not using any extra data structure, but because we are using sorting algorithm, that will be utilized by these functions. So depending on your language that you will be using, in Python it can be big O of n, and it can be log n in C++ or Java. Because Python uses dim sort and C++ and Java uses other sorting algorithm or an amalgamation of other sorting algorithms. It depends with which programming language you are working and which sorting functionality you are using. So on the basis of that, our space complexity can vary from big O of log n to n. So this will be the space complexity. And honestly, I am quite satisfied with this approach and this solution, but your interviewer might not be. So if in case your interviewer will ask, like, rather than sorting mechanism, is there anything else that we can solve this question with? Then yes, we can solve this question with something else. So just for that, I am going to tell you only that much part, that the approach that we are going to use rather than sorting, because rest of the approach is same. And I won't say that that is the optimistic solution or something, because it is not going to affect that much, but still it's good to know multiple ways of solving these questions. And if in case your interviewer is in that state where he or she wants to know what is your level of understanding of these algorithms and techniques, then it is better to know few more things. So just for that, we are going to solve this question with one more approach. So as we were using sorting in order to get the sorted array, but there is another data structure that we can use rather than using sorting mechanism, and that is priority queue or heap. So what heap will do is, heap will give us the values in sorted order. So like, if I am going to create a heap of this this array, it is going to convert it into this thing in sorted order. This is the max heap. But in Python, we don't have a concept of max heap. So what we are going to do is, we are firstly going to create a array of negative values. So what this will do, this will make these values as -4, -5, -3, -2. So now the number which is the largest positive number that we have in this array will become the smallest negative number, and it will become the first element in this heap. And in this way, we used min heap as max heap, because in Python we don't have max heap concept, we only have min heap concept. So we can use it for our purpose in this way. So now let's see, after creating min heap, the whole procedure is same. Only the part where we were, calculating the happiness and adding it up in our result, we simply have to update our result with minus of whatever we calculated. That's it. This is the only thing. We only have to convert the sorted mechanism part with the heap concept. And the time and space complexity of heap of this approach is going to be like, we firstly have to create a heap, and that will take big O of n time. After that, we are traversing this heap, and every operation in heap like insertion or deletion will take around log n time. And we are doing these things for how many elements? We are doing these things for k elements, because we are going to run a loop or traverse the array for only this much steps, correct? Because we only have to get these many childrens. So we are having this time complexity, where for k number of childrens we are performing operations on priority queue, but we are creating priority queue for all the childrens. That's why it is big O of n. So overall time complexity will be big O of n plus k log n. And space complexity is going to be big O of n, as we are creating a heap for all the childrens. Now let's quickly code this solution, and I'm going to code both the approaches. So now firstly we are going to sort our array. So in this manner we are going to sort our array in reverse order, because we want the largest value at 0 index. After sorting it, we are defining our variables, that is maximum happiness, which we are going to calculate. So currently it is 0. After this, we are going to run a loop for I in range k, and we are saying now update our maximum happiness with max of what? Firstly, the value, that is nums I minus I. We already discussed why we are subtracting this, because we have to maintain that decrease in happiness condition, right? And we are checking maximum with 0 because we don't want our happiness to be negative anytime. We want it to be positive always. So this is it that we have to do inside this for loop, and after this we are going to return our maximum happiness. Let's quickly run this and check. Okay, there is a typo. In most of the question we are having arrays as nums, so I wrote it nums. It is happiness. So let's quickly submit this and check. So we can see that this approach is also accepted, and it beats 62.82%, 82%, which is something that I don't trust. So now let's modify this same code for the another approach, which is heap one. So we are going to create our maximum heap, and in this we are going to firstly make all the values as negative, right? So for I in, again I was about to write nums, which is happiness. For I in happiness, we want to do it minus I. And after this, I am going to heap q dot heapify max heap. So once we are done with this heapify part, our heap queue is ready, or our priority queue is ready. And inside this for loop, what we will do, we are going to do heap queue dot heap pop, and inside this we are going to pass max heap. We also have to add that negative sign, right? We have made our values as negative, so we will add this negative sign as well. And now we will again check. So this is also accepted, and let's see. Okay, this is 8.99%, and previous one was capable of beating 82. I know that these percentages are not reliable, but yes, we know that both the solutions are acceptable, and there is not much difference in terms of complexities, but definitely it's good to know what are the alternatives of sorting or heap queue. If you don't want to use a data structure, you can go with sort function, and you can do it, and your solution will still work. But just to be a bit more knowledgeable about data structures and what all alternatives we can use in a question, we used two approaches. And I hope this video was helpful for you all, and if it was, then you can like this video, subscribe my channel. I will soon come up with more such questions. Till then, keep messing with algorithms, and as always, thanks for watching.